Hi, and welcome back to Algebra 1. Our goal for today is to continue working with solving systems of linear equations using the substitution method. No matter what method we use to solve a system of equations, all methods lead us to trying to find that point of intersection where all of the lines in the system would cross or intersect with one another. So when we used our graphing method, that's what we did. We made a picture version and we located that place where our two lines or maybe three lines or four lines crossed or intersected with one another. Sometimes using just a picture is difficult to find that place of intersection. So in our previous lesson, we added in how to use what's called the substitution method for solving a system of linear equations. When using substitution method, your first step is to isolate any of your variables. Top x, top y, bottom x, or bottom y. The ones that have positive 1 coefficients are the simplest, easiest ones to isolate. From there, you take your answer you get in block 1 and substitute it into its location of the other equation. Once you do that, you'll have an equation that only has an x or only has a y variable that we know how to solve. Solve it. Once we get our answer there, we take our answer from that second block and substitute it back into our result that we got from block number 1. Once we've done all those steps, we'll have an x comma y of the place we think our lines would intersect, which is the solution of our system. So our last step is check it because it has to work in both equations. If it doesn't, we know we made a mistake and we should go back and change our results and look for mistakes. So picking up where we left off yesterday with our examples, number 4. All right, we want to solve this system, y equals x plus 2 and 2x plus y equals 8. Now, this is a little bit of a special case because we have one of our equations is in slope-intercept form where there's already a variable that's by itself, which makes the substitution method ideal and quick and fairly easy to use because that eliminates having to do anything in block 1 of our work. So in step 1, we're going to say, all right, I'm going to just use that y equals x plus 2 equation because it's already y by itself. And so this x plus 2 can get substituted in over here into the y location of 2x plus y equals 8. And remember, this is a 1y here. So 2x plus 1 times x plus 2 equals 8. And then we can just bring that down here, y equals x plus 2. So if you already have an equation where you have a y equals or maybe an x equals, you want to use that one in step 1 because it's already done for you. All right, distribute here. So we have 2x plus 1x plus 2 equals 8. All right, let's combine our like terms. We end up here with a 3x plus 2 equals 8. Once we get here, it's a two-step equation. We want to get rid of that add 2 first by subtracting 2 from both sides. All right, cancel on the one side. We end up with 3x equals 6. From here, we can divide both sides by 3 to get that we think our x coordinate of our point where our lines cross or our solution is at 2. All right, we can now take that answer and substitute it in over here to solve for y. So we have 2 plus 2, or we think our y coordinate of our ordered pair over here is at 4. All right, so we think our solution here is at 2, 4. Let's check it. 4, does it equal 2 plus 2? Now remember, this is your x, this is your y, so be careful when checking. All right, do your add here. Yep, 4 does equal 4. Right over here, 2 times 2 plus 4, would that actually give us 8? All right, 2 times 2 is 4, so when we take 4 plus 4 and we add it up, we do get 8 equals 8. We're good, it checks out in both, so our solution to this particular system of linear equations would be at 2, 4. All right, let's try another. Example number 5. We want to solve the system x plus y equals -3 and 3x plus y equals 3. And remember, this is a 1x, a 1x, 1x, and this is a 3x. Any letter that has a positive 1 in front of it would be the simplest or easiest to solve for. So top x, top y, or bottom y. All 3 of those would be fairly simple to solve for or isolate. Since most of us are more comfortable solving for y, since we've done that a whole bunch when we've gone to like slope-intercept form or function form, I'm going to go ahead and say let's use this top one y here in step 1. But again, we could use the top x or that bottom y. All three of those would be simple and easy to work with. All right, so we decided we're going to use that x plus y equals -3 equation in this block, and more specifically solve for y by removing this positive x. So we're going to subtract an x from both sides. So y equals -3 minus 1x. All right, which means over here we need to use our 3x plus y equals 3 equation. All right, this entire thing goes in here for y. Now remember, that's a 1y. So 3x plus 1 times that entire thing, -3 minus 1x equals 3. All right, distribute, and then we're going to have like terms we can put together. And we'll be back to a two-step equation. So 2x minus 3 equals 3. All right, two-step from here, we're going to add 3 to both sides. All right, once we did that, we'll have a 2x equals 6. One step from there, we're going to divide both sides by 2. And we'll end up, we think our x coordinate is a 3. So our place where our two lines would cross, we think is at 3 comma something. All right, bring this guy down. Y equals -3 minus 1x. So we're taking this 3 and we're going to substitute it in here for x. Don't leave out this -1. You need it's -1 times 3. So be careful. All right, so y equals -3 minus 1 times 3. All right, multiply here. We have a -3. 1 times 3 would give us 3, so -3 to get y equals a -6. All right, so we think our place of our solution is at 3 comma -6. Remember, it has to work in both equations to be the solution, or we made a mistake somewhere, so we'd have to go back and find it. So we want to check. 3 plus -6, would that actually give us -3? Yep, 3 plus -6 would give us a -3. We're good here. All right, over here, 3 times 3 plus -6. Would that actually give us a +3? Well, 3 times 3 is 9. So when we take that and we add to it -6, yep, we do get 3 equals 3. So it checks out. Using our substitution method, we have discovered that our solution to this system of linear equations is at 3 comma -6. All right, I hope that helps you attack your work for today. Have a good one.